of 1 equals 0, and use this fact to factor p of x completely. So they want us to show that p of 1 equals 0. When it has a remainder of 0, we learned that it is a factor. Well, where do I start? P of x equals something, like a number, so therefore x is equal to 1. I'm kind of showing why it's equal to 0. I can use the remainder theorem. The remainder theorem from Friday's lesson is that if you take this x equals 1 and we put it in for every x value, I have p of 1 equals 1 cubed minus 7 times 1 plus 6. Class 1 cubed is negative 7 times 1. 1 minus 7. And negative 6 plus 6. So using the remainder theorem, I've proven that when an x value is equal to 1, your remainder is equal to 0. Now, you could have used synthetic division or long division. Remember, x is equal to 1. What's the binomial you would have used for long division or synthetic division? Well, it's set equal to 0, so you would subtract 1, and the binomial you'll get is x minus 1 equals 0. So here, this is what you would have used for long division, and this is what you would have used for synthetic or remainder theorem. So we just showed that to get a remainder of 0, I can use either of those methods. The second part says, use this fact to factor p of x completely. Now, let's say we wanted to use synthetic division. So let's review synthetic division. I have a 1. Class, what number do I write here? 1. A 1. What's the next number? 0. Next number? Negative 7 and 6. Where did the 0 come from? So that would have been x cubed plus 0x squared minus 7x plus 6. Let's review synthetic division. I bring this down. What number goes here? Multiply. Add. Multiply. Add. Multiply. Add. This shows you that the remainder is 0, and yes, it's a factor. What is a factor? This is a factor. We've already proven that this is x minus 1. Class, what does this represent? What do I write here? Negative 6. How about this one? X. This is a 1x. This 1x is a positive or negative? And this one? 1x squared, or x squared. Now it asks us to factor completely, so I'm going to have to take this and see if we can factor again. Class, a times c? Negative 6. Your b value? Two numbers that multiply to negative 6 add to be positive 1. 3 and 2. Which one is negative? So these two numbers become x plus 3, x minus 2, and then you have this one as well, x minus 1. And here in orange is our final answer. In this problem, I reviewed how to use the remainder theorem to prove that your remainder is 0. You could have also used a synthetic division. The synthetic division tells us how to factor completely, where I can take my binomial and my leftover, or my remainder, we can actually factor again.